Hey, welcome to Coffee Compiler Club at the daylight savings time split in the universe. Here today to talk about compilers and language implementation and design. Everyone's recorded. We're on YouTube in a couple hours, assuming I get my act together. And that's my lead and spiel. And Levo, you had something you wanted to talk about. Levo, seconds ago, you were just talking.
He's still muted.
Yes, he muted himself, but I assume he also ran off to go do something. Well, then, too late. I'll go pick something here. Um,
Is my
Last
microphone not
week.
working?
Oh, now it's working. Yeah, you were muted. Now you're not. You want to go?
Oh, yeah. So last week, so LLVM is I was thinking about how LLVM is slow, and I have no problems with that, but I couldn't quite figure out why it was slow because people on the internet make things up. I was thinking one of the problems is when they do a pass, they do it on everything is instead of like two previous passes neighbors like CV Node does. And then besides that, I couldn't think of a plausible reason why it might be slow. I was
Yeah,
wondering if anyone knew here.
I have some easy answers, but I bet Matt has too. So one of them is that their IR is big and bulky, and that just means you can't fit as much in your L1 and L2, and every pass takes
Oh,
longer. There are a lot more passes. That's part of the I'm not incremental, like C of nodes. Most of these common passes are all done incrementally in a single big pass. So you get hundreds of passes, literally hundreds, instead of half a dozen. And then the IR is bigger, so it doesn't fit in your cache, so you're streaming IR in and out of your cache endlessly.
so a pass doesn't run through every single node. I mean, every single thing in the function.
In LLVM,
Yeah,
as far as I know, it does. Matt
it
can correct
does.
me.
Okay. Okay. No, I must have misheard. Okay.
I mean,
And
they definitely have some SSA times when they go in and out of SSA is, makes more passes. But while you're in SSA, there's an easy incremental way to do a bunch of things, and I'm sure they're taking advantage of that. Um,
okay. So the reason why I was thinking about this was because I saw someone talk about how brute force is not expensive if you can rule out 95% of things to test. And you would just have to like know something about the data to be able to say, if I do this thing, you can just skip a bunch of other things. Like one example was if I choose not to do some step, I don't want to do it then like the next round. So I would just have to like remember that don't like do this thing in the next round because otherwise it's just repeating work, and that's how you would like rule out a lot of work like brute force work. So when I was thinking about the LLVM and all that, so I was like, um, what's like because I know instruction,
I
I
would
know.
back up. I would back up a second here. When you say brute force, what I think is you're going to go through a large thing doing something fairly simplistic as opposed to trying to be clever and avoid work. You just do the work, which can be cheap if the large thing you're going through can easily either fit in cache or string through cache. And then it's just memory bandwidth divided by amount of material to how long it takes. And so, brute force can be cheap if if it's enough easier than doing something super clever. Um,
So what I was thinking was okay. So I'm not thinking of register allocation because I know that can be expensive, but I was thinking about instruction selection because I heard that's where people would want to brute force something. Is that true?
um, I don't know what LLVM does. For instruction selection, not scheduling, but selection, I do a one-shot, one-time pass over the IR and flip the nodes from, the ideal version to the machine version. And that is, I mean, it's a straightforward pass. I've tried clever things. They don't help a whole lot with instruction selection. So I just do dumb brute force, greedy first grabs. Um,
Mm.
I would claim it's kind of a brute force approach. It's certainly a dumb one.
Okay. I'm gonna have to think about this more. But one last thing was I remember you talking about doing heuristics for optimization. What are the heuristics for? Because if it's not trying to eliminate work, then
Well,
I'm not
inlining
sure.
and unrolling are two big ones. You unroll until you blow out your iCache and then you lose. So you don't unroll too much. And then
Oh, right,
no,
right.
yeah, no, anything that grows code in order to save code, right? And so, or save cycles, add code to save cycles. You have competing interests, so you end up with heuristics.
I don't think anyone will like. I don't think any compilers says, "Okay, let's try to unroll the loop and then back out if it turned out to be too big." Like,
No, but
does
you
anything do
you
that?
ask questions before you start enrolling, and then your
Okay.
heuristic kicks in there. It's like I go count members of the loop body. How big is this loop body? And then I ask also how much what's the estimated execution frequency? If I'm profiling, I have pretty good numbers, but C has static heuristics they've used for 30, 40 years that are pretty good. You come with a execution count and a size of the code, and then you decide I'm going to double it and blow out some more iCache in exchange for getting a chance to fold two loop bodies tighter together and do something. And then maybe I double it again and double it again until I got too many doublings and I stopped. So anything that does walk through a bunch of bytes, like any network code, and do something almost surely wants to be unrolled enough times that you can do sim deops on the thing. And that means you're unrolling by fours or eights or something like that.
Okay, I see.
But if
Makes
you're,
sense.
flip side, of course, is if you keep unrolling until you blow out your iCache, you lose. So there's a dancing game. No one claims there's a perfect answer, and now you got a heuristic.
Okay. That's all from me. I
Yeah,
do
no,
have a
it's
funny story, but that's all my question.
uh,
Okay, I'll tell my funny story since no one jumped in. So the other week I was testing an optimization with GCC, and then I'm like, oh, I wonder how fast Clang will go. And it turns out that Clang decided to not inline a two-line function.
I don't understand Clang. It's fine, and that made a big difference. I take it.
Yes, it made it like I think it almost I think it was like 30% slower than no, it was 50% slower than my optimized version or the what GCC produced. Uh,
Yeah. Now go ask the question. What mysteries does Clang use when it decides to inline or not? I don't
well,
know,
I
but
checked the remarks and it turned out it inline. So the first line of the two-line function was if this rare case, call this function.
okay.
And it decided that the rare case was not rare, inlined it, and then
Hmm.
the extra line after that happened to make it cost like a little too much.
Right.
So it decided to not inline anything at all. And it was just like, really?
That is a common problem with heuristics. They're nonlinear. So looking at a single instance, you can always find one where the heuristics of the day suck. And then you kind of have to look at a large corpus and say, I can tweak the inlining heuristic a little bit, and this guy loses and that guy wins. And on average, what happens? Is it better or worse on average? Um,
I'm surprised it didn't back out of the if statement when it realized it was too much.
Well, there's also like a likely and unlikely annotation that you can use, and that can help this with this sort of scenario. Or you can use profiling.
Well, to go back to your back out thing, I don't know of anyone who backs out of an inlining. Like the first thing you do is you inline, then you run optimizations on the inline thing, and it maybe completely folds away, disappears utterly. There's no point in backing it out because it's just gone. But if you've then done optimizations and it didn't clean up completely, unwinding the inline almost surely means you have to like snapshot the IR and then roll completely back in time. Like you're not going to get a
Uh,
clean unwind. You're going to have to, because you would have made other optimization changes while you were busy trying to fold up the inline thing.
I
So,
imagine that might have been cheap on Sea of Nodes because you do the pool thing where you just copy to another pool and
So here's the question though: if you do the unlikely annotation, do you still have the same problem? Like if you do
no,
open
that actually
open
fixed
unlikely?
it.
Yeah, yeah. So that's all you
When
got
I
to do.
realized what was going on, I tried that immediately, just
yeah.
putting unlikely, and that solved it.
So basically, you've got he had no profiling data, and you're handing him profile data manually, and then he gets a better decision. Which, yeah, everyone on the planet.
Yeah, the compiler is smart, but it's not that smart. You got to hint it sometimes. You got to be like, hey, this is
There's the whole reason for profiling from C2 is it gets to get the profile data, and then it gets smart about these things, and so you get better inline decisions, and as well as better unroll and all those heuristics.
This conversation is making me think that if I ever do an optimizer, I will always need a profile.
Yeah, it's really helpful. The thing with C is it wants to be static ahead of time, and then you're ahead of time, so you don't get any profile. So then you want to say, oh, but I want profile guided optimizations. I have to run profiles and have them for the next go around. And that severely complicates the build process where you have to build your compiler, where you're going to collect, then you run under some test cases, some corpus of code, and you've collected, and now you run again with a compiler to go use that profile data. And mostly when I was, young guy till the 40s, no one ever bothered. It was just way too complicated. The hardware vendors did it to get max spec scores, but no one else on the planet ever did it. And then C2 in my head was kind of this big jump forward in that I always had profile data all the time. And oh my God, it made such a difference. And then once you had it and you knew you were going to have it all the time, you both knew you were going to use it. You didn't have heuristics that dealt without it because you just had it. But you also looked at how you could collect it cheaply on the fly. And lo and behold, there's a lot of ways to collect a lot of data that's pretty cheap to collect. That's really useful for the compiler. So you collect all this cheap data. Now you're thinking that you're going to collect it and you know you need to make it cheap so you can have it on all the time. And you got good, cheap profile data. There's a positive synergy there.
Yeah,
The
that
sum of
sounds
the
really
parts is
useful.
so the whole is greater than the sum of the parts.
Good cheap profile data that we've given to the compiler, not necessarily that we've given to the developer.
Yeah, yeah. One of the fun things that I came around with was the adding the web service backend to C2 to the JVM that lets you poke and look at the C2 generated code with all the profiling data and all the Java annotations and every other thing in the planet. And the developers were like eyeballs just pop out of their head, like, holy crap, where does this come from? Oh my God, best thing since sliced bread. They're just desperate for it.
Yeah,
Um,
I mean, that was one of the most amazing things the Twitter JVM team managed to do was aggregate the counter data from JVMs from 300,000 JVMs that were running something and get it all the way down into the language server so that you could highlight lines and be like, hey, by the way,
this line
this
runs at the
one
same time.
function is called a lot. If you can save an instruction, please
Yeah,
do so.
do something useful here. Yeah, yeah.
I
Yeah,
didn't
I
realize
never
that.
got 300,000 machines, but I certainly would grab onesies and twosies and take them to people and who are asking, and then we could get 20, 30% speed ups because they just didn't know. They had no
That
idea.
to me was one of the most surprising things to come out of this research was that pulling one machine tended to give you very different results than pulling 300,000,
Yeah.
but pulling five gave you about the same results as 300,000.
Wow.
Ah,
Like the
excellent.
gains you got for adding another machine to the profile were
Okay.
you got a lot by getting off of one machine and you didn't need that many.
And you need that.
okay.
And that's a good one to know. That's a good one to know.
I'm told
So
there's like deep statistics as to why that's true, that you can take
D
10 samples from a million samples and get reasonable statistics about the set, but
No, it says
Twitter
that
actually,
most people are in the average case. The
yeah,
median is big. And
I
if you happen to pick somebody outside the median, you got the wrong answer and you didn't know it. But as soon as you got five, your odds are you're almost always somebody's in the median. Most
yeah.
folks are in the median. Yeah.
It's hard to calculate a mean from one data point. It's not so hard to calculate a mean from
There you
three.
go. Yeah. Yep.
so I actually have some uh syntax or I guess internal design I wanted to run by you and see what your thoughts on how well this would optimize would be, Cliff,
Yeah.
since you've
You want to share?
so I
Or Doc, I
yeah,
should
yeah, sure.
bring the
Yeah, I'd
doc
love to
up.
argue about syntax.
Uh
quick
yeah, this
question,
this
Aaron. So Twitter actually had like an LSP that they built. Like that's yeah, I had no idea, and I think the only one I heard of was the one that Microsoft and I don't think it was Oracle, it was someone else that or Red Hat made with them. I
I
think that's the
think
only
there's
LSP I
some
heard of.
existing Java LSP that they were able to just inject more data into.
Okay, let
Oh,
me.
interesting. All right.
Okay, so basically, let's say that I have like I have a var x, and that's an array of four something, right? Um, so this is kind of like, I guess, a question about like how I represent the initialization of an array. Because what I was doing with structs, right, is that I would say struct, like basically I have slots, right? So there would be like a slot. So let's say this slot one. This would be like of type four something, right? And then there would be,
When you
or
say
like let's,
type 4, you mean size 4 array?
yeah, yeah. So this is like an array of four somethings. Okay. So I guess let me
Okay.
do this with a struct. Let me do this with a struct. Okay. So let's say this is a foo struct, right? And so you have the foo struct slot, and then let's say that it looks like, foo struct, and then it's a class, and it's got dot x
I'm,
var
I'm
hyphen
trying to
x2.
rewrite your code as you're doing it in a Java-like syntax, so I have an easier time understanding what you're doing here.
Okay. Yeah. So
Yeah.
basically this. Okay. And so in the struct case, it'll create three slots, right? So it's got the slots like
I
this.
mean, you three slots, you're talking about memory layout includes a header,
So
which
so
in Java is the mark and
slot
class word. Yeah.
slots are like part of the generated IR. They're not necessarily in the struct. So like these are like kind of like registers, but they're not registers, they're slots. And I'll explain
That
I'll do
didn't
this.
help
So
any.
okay. So
So
basically uh
are you describing the layout of a foo struct when you have the one colon, two colon, three colon?
no, this is the IR. So I'm really focusing on the
Okay.
IR. So let me explain like the entry points of the function here. Like so we have like parameters, all right, and then there's going to be, let's say, I don't know,
Yeah, so
parameter
so far you don't have a function. You have
this.
a class and you have
Th-
some
th-
IR, but with no function yet. Okay.
yeah,
Now you're getting
yeah.
to some IR.
So this is like the how do I create this like the
How do you have an IR for describing the creation
who's
of a function of a struct?
whostruct dot constructor. This is basically like I'm creating the foostruct, right?
Yeah.
So this is the constructor, and the parameters. This is of type new slot of foostruct. Okay, and then that's going to be at one, something like this, right? Uh, and it's assigned to slot one as part of the parameters, right? And then so we have like block zero, and then we say struct delegate. Uh,
But way too much wordage for
Here,
IR, but okay.
yeah, and then we say one, and then we say okay, dot basically x equals two, y equals three, something like this, okay? And then we can say load const int, and then we can say okay, two. And we're gonna set that, I don't know, that equals zero, and then maybe I
Yeah,
don't know.
put
Let's
put
say
like 7 and
let's
11 because their prime is and no one accidentally writes them, and you can tell 0 from pre-initialization versus I actually wanted a 0, right? So now I know you really mean a 7 there, and the 0 isn't magic some other stupid way.
yeah, let's say I initialize them with some default args. I don't actually
Yeah,
have that implemented, but
yeah, right. You've already got
so
them with a 2 and a 3. Now you're putting in some more stuff here.
so this is like okay, x equals like
Yeah.
basically slot two, and
Oh,
then y
slot 2.
equals slot
Yeah,
three.
okay. I see.
So what this is doing is it's saying these go here, and then we can do that we just read, right? Okay.
Okay, so are you making a memory object or are you making a stack struct and then returning it, which you're not really returning it. So you're making a
So
memory. You did a memory allocation. You said a new. You have a new up there. I see the new. You're asking what I would do for an IR, or are you asking how you can optimize this?
Okay, so let me first explain what this is doing, and then
Uh-huh.
I can go to the array case and
Well,
explain
but
sort
I
of the
think right. So explain and then let me re-echo in a different way, and maybe you get some ideas of what's going on and make sure that I understand what you're saying. So finish up what you think a struct new is doing, although I have a pretty good idea.
so the state at the start is like 1 equals partial
Right.
storage only, and then state equals like 1 equals well, or just like
It's fully initialized.
just
Because I was
storage
just
only.
fighting this week, well, this last week, and redoing simple initializers because I was trying to redo CL inits. I had to do inits, and then so I was doing inits just this week.
And then 3 equals storage
Yeah,
only.
you have more notions going on here than I do on purpose, which I think aren't helping you.
Okay, so basically what this does is it says these slots
Yeah,
are actually delegates of this, which means that these slots now refer to like data inside of this struct.
right.
So these slots are actually kind of like referencing the
Yeah,
data that's inside this struct, rather than being like a local slot.
yeah.
So you can have
This sounds very old school compilery, and I'm not going there. I'll do the same behavior in what I claim to be a much semantically simpler way, but you can argue that you believe yours and I
Okay.
believe
So
mine. But
so the reason why it's done this way is mostly so that it can generate unwind tables. Like so if there's an exception, let's say instead of load constant, this called a
yeah,
function that did something and
I
then you
can
could
do
throw an
unwind
exception.
without, because I've done unwind in C2 forever and a day. I can do without this kind of stuff either. The
This
unwind is an unrelated problem here.
You don't have destructors in Java, do you?
No.
So that's why you don't need it.
Oh, no,
But
no, no, I totally can do the unwind. Java has no
okay.
built-in destructors, but there is a try finally, which will do effectively the unwind thing. There's also try with resources, which effectively calls a destructor or close. So you have them in Java, and they're done as syntactic sugar
Well,
without
I guess
EP.
the idea is that I don't need to create separate blocks for try and finally because like every like I would have to be like
Right.
try construct this member finally
So hang
do
on.
this or like exception do that. Like it would
Right.
be very messy because like there's so many
Back
unwind
up.
paths.
So certainly no one needs to do blocks for this. This is just IR. And the IR, whether it's a block or not, is sort of unrelated to anything. If you end up with a block in the end, you do, but it's not a driving to the design of the IR. I don't care about blocks when I'm doing my IR.
Okay.
And I don't know why I would if I had finalizers either or destructors. Did make no difference. So blocks are not part of the issue.
So I guess the purpose of this is so that I can keep track of what fields are currently alive. Like if
Yeah,
I throw an exception in the middle of a block, I know like after each
right.
instruction, I've tracked the state of each slot, and therefore I know which slots have destructors that need to run.
Right. I get it. So let me show you a different way to think about the problem, if I get a chance here, which I'll have to go do a little bit of mess around here. So replace I32s in my little example here with something that needs a destruction logic here. So let's call this, I make a lock thing, and oops, and I make a file thing. And now the thought here is that something fails at the file level when I'm creating a foo object. I have something to lock and a file to open, and I fail on the file, then I'm going to have to unlock the lock on my destructor. And there's a Java syntax which doesn't really matter here, which has, finally, which is basically calling, foo.unwind, however it's done. So when I look at this, I'm going to break it down into the most simplest portions of straightforward code I can imagine, and then do a direct translation to IR. And that means that's going to be as if I'm not actually going to write the following code. I'm going to run it as if the following thing's on here. I'm going to say I make a foo object. Foo is a new foo with no fields. Foo prepared yet. So they're all going to be nulls or some other thing like that. And then I'm going to say foo.lock because that's the constructor of the lockable, and it's actually foo.x.lock. And now I'm going to say foo.y.open of, file me, except I have to have a fail mode here. So this is includes an if fail. So this is success. Close paren, whatever success means. There is an else fail, foo.y.fail path, right? And then in the fail path here, I'm going to say unwind whatever y, but now I know I have done lock. So whatever I do with fail here, and then I have to do foo.x.unlock because I'm unwinding. And then I'm going to throw out because whatever that means because I blew out the file open. And I'm trying to say this is like the partial destructor at this point in life. So imagine that this whole thing is really buried in the foo init as a function call, and I'm going to return you the foo object in the end, or I'm going to throw out and say, it failed halfway through. And then I'm going to inline. So this is going to return, So when I create this foo object, I have this series of events that I'm going to roll up into an init, but I'll inline the whole pile of inits and make a foo object and go unlock it. And then if that works, I'll go on to the success path, which eventually returns a foo, or I'll throw out here, whatever, I'll fail out on the Y and I'll unlock the X and throw out. Okay, so that pile of text there as IR has embedded internal control flow.
Yeah, I wanted the unwinding to be implied because it greatly simplifies the IR, and also like if I put if statements, that's going to
Okay,
introduce like a
so
branch,
so
which is going to be
so
slow.
the grand success I did with C2 was I put all that exceptional IR straight into the IR. And so the IR remained simple semantically, but it blew out in size because you had a lot of test and else and then and fail and whatever. So the grand success out of that was all your junk IR for doing success or fail paths where you had exceptions of this and that got optimized by the normal optimizer, and he removed dead paths and he prioritized with frequency. He knew the frequency of fail was low, and so he would shuffle things around to make it higher or lower performance or whatever. The only thing going on here that I had to deal with was throw, unwind as an entire stack frame and however many to use caught. And that was true always, no matter what I did. Since I had to handle unwind or throw and remove frames, it didn't matter if I threw them once or 1,000 times. In practice, they only threw when you threw an exception, it's rare. And in practice, they had to work, so it was available as a tool. So I just called throw whenever necessary. So they are included lots and lots of throws. In particular, this path here on this fail path would almost surely have been a deopt, turned into a deopt, which was a version of a throw that said, "Oh, Mr. Interpreter, please do the Y fail on the unlock and then throw again." But the optimized code just said, "Oh, the return from open was success." Fall straight into the next step, which is foo, and you got inline, and your code looks like
Yeah,
if open success, then carry on. If not, if open fail, deopt. So the optimizer had this nice, clean, straight line code for the success path. And the fail
yeah,
paths generally got cut off to a deopt at some point. But by exposing the check IR and the unwind handling IR, the optimizer got a chance to go after it. And this shows up again and again and again, null pointer checks and range checks and every other
yeah,
safety check that you repeat 1,000 times over. The optimizer cleans all the extras out and makes life, fast and easy for the fast
yeah.
application.
LLVM can sort of do that too. So my thoughts here was like, okay, I'm going to be generating LLVM, but the IR itself is a little simpler than the generated LLVM. So that the branches are there, and like when it translates this to LLVM, right? Like it's going to generate the else block with the VM, like whatever the instruction in LLVM is that is like a function call that can throw because
I
it
guess
gives
I'm
you a true.
encouraging
It,
you to be explicit about the checks and the fail and the unwind paths in the IR because it lets the optimizer clean it out and because it lets you look at it and understand what the semantics actually are here. I have talked to a bunch of people who implemented variations on JavaScript where they all had special handling for blocks that had fails in the middle, and so the block could abort halfway through. And they kept running into God, I got a problem here. They kept running into issues where they just had a more and more and more complicated IR because they had to deal with failing in the middle of a block.
Yeah, so
And
there's only really two complications, I guess. One is like when I'm creating a struct, and then the other is like if I'm creating an array. Because like otherwise, like if I create a value, it always knows like in every point in the IR, it knows if that value is alive or not. Like it's fixed, and there's something called state engine, which is
okay,
like a
yeah,
static pass. Like
hand in
it's
hand with where you're at here is I don't make a preset of slots. Every node is a new value, and they just come and go as I make nodes. So I don't have to pre-allocate however many slots and then decide they're live or not. If the node exists, it's live, and if it doesn't exist, it does not, and that's the end of it. And so I don't have this question, is a slot live or not? Um,
Yeah, so the
just know that it
slot
was not.
lifetime is used to like generate the unwind table or like
Right,
theoretically,
right.
right?
That's what I'm saying. You're making yourself work for yourself. Whereas in my version
I
of things, the unwind doesn't have a slot to say go after. He does know that some fields have been done or not,
it,
and that's
it
why
it may make it more work on the translation of IR to machine code, but it makes the generating the IR much simpler, which is
all right.
the
I,
more
I
work
will
from my
I
perspective.
will respectfully disagree. It made generating the IR much simpler.
Okay, so I'll give an example. Okay,
You gave an example, and I claim my example feels a lot simpler to me. You get another example. Yeah, go for it. But I think you're not going to convince me of things that I have done for 20 years and really liked how they turned out.
let me find the and statement. Statement. Where's my expression and? Okay.
You want to go down
Yeah.
to a different block here?
Okay. So like I will let me see if I can copy this. Paste this here. Okay.
I'm trying to figure out where
Um,
you're editing.
yeah, I'm gonna go one down here. So like this
Okay,
is
I'm going to center it.
kind of uh some early like generation here. This is why I went with the way I wanted to do it this way. So like um if I want to generate an and statement, right? I basically say, okay,
When you say and, you mean an and a
yeah,
logical
yeah,
test and jump around the other clause,
yeah.
a
So
trinary.
I can create results left hand side after and then
You have to test before you do right hand side.
yeah, so let's see. It does so we generate block, logic and false, logic and true. So we have the true block, the false block, after block, and then we have something evaluate the left hand side. I probably need to get rid of that. That should
Well,
just count.
so what you're doing here is showing your IR for a logical your code to generate a logical IR as a way to go generate. And how that code looks, the generation itself code looks, depends on how your building blocks that you've assembled
Right.
building IR. You're going to build some chunks of IR. And I
So
have
so
similar IR building chunks for doing a logical and they're similarly sized.
So this is able to handle like if any objects that are created during the evaluation are have destructors, the unwind for this will be correctly generated
Right. And
because
so same for me for the same reason.
yeah, so this like because the destructors are just like implied by the existence of a value, I don't have to be like, oh, if this has an exception, like I don't have to be like, oh, if the result of this branch was exception to
Yeah,
do this or
I'm
else do
not
that.
either. There's nothing special about what I'm doing that requires me to do more work here. That those are all come out as the normal mechanism that said, hey, I have a thing, I threw an exception, I could do another thing. That there's a standard boilerplatey thing that just runs through and spits stuff out. And I don't think
Just
about it at
admit the
this
control
level.
flow nodes that are if and loop, or is there a different control flow node specifically for that case?
You
There's
talking
just a
about me
branch
or Ryan?
instruction.
I'm sorry, Aaron, were you talking to me or Ryan?
I was talking to you that
I
whether
haven't.
these exceptions
My,
are a different control flow structure than
no,
just if and
my
loop.
exception control flow is identical, the same as the normal control flow. The sole exception will be I have a frequency estimation if I don't have profile data. And the frequency estimator has some heuristics based on, I think this is an exceptional throw versus not. Otherwise, it is a totally standard, bog standard, simple if node, nothing special. And that was what I'm saying. That's one of the big wins is I didn't have to do anything about the control flow that was weird. I just spat out normal control flow and the optimizer cleaned it up.
I guess my intent is not to do that specifically, is not to have branches in the middle of code to handle, exception
Wait,
unwinding.
semantically you do. You have an unwind point where you throw an exception in the middle. So semantically you have a branch. Now you don't represent it in the block, but that means your block actually still has to know at this point I can't move things above and below the block. I can't do list scheduling of the block without
Right, but I
concern.
don't necessarily introduce a runtime branch in the non-exceptional case, which is I guess where the reason why I want to do it this way
Yeah,
is.
okay, and I
That's
don't
the
either. No, I don't either. The branch that you get if somebody's going to throw depends on the kind of the reason that they're throwing.
I don't understand
Right?
how you generate unwind tables if you're using the same instruction for regular branches and exceptions. Like how would you generate an unwind
Okay, yeah,
table?
I don't I don't generate unwind tables. I
Okay,
generate a call to a safe point which has the exceptional information buried into it.
yeah,
And
that
that
sounds. I mean, you can go over the whole argument of like exception versus not exception for control
I,
flow.
yeah, and I'm doing the Java exception and you're doing the C++ one, but I think they're pretty close here. So what I said was the semantics of an exception are do these things, unwind, unlock the lock or whatever you're going to do some work that was part of the destructor, and maybe you had to have some results that were available only on the exception path and not on the other, whatever that was. And then you begin unwinding the stack. And that the unwinding the stack is the runtime piece that the unwind table feeds into. So for me, the unwind was I essentially jumped into the interpreter and unpacked the running C2 frame into a bunch of interpreter frames that were properly filled out with all inlining and the like at the point the exception was thrown. And then the logic said, I'm going to start throwing interpreter frames until you catch. So that's the runtime piece. So the runtime piece said, unpack the stack. So to unpack the stack, I had to have enough information to rebuild the stack frames as if that's what they were had you not inlined and optimized and done things. And that meant I kept alive whatever debuggable things that were going to be visible in all the unwinding points. And that's the job of a safe point, which from my view, from the optimizer's view, is a fancy call and it takes a bunch of arguments. And buried in with that table, that call is a unwind table for that call that lists where to find all the things, which arguments return to what registers, we go to which variables, which things are just constants and I can just manifest them directly, which allocations I escaped away, I have to go make for the exceptional case and whatever. So you're saying unwind tables, I have a node that doesn't unwind? But semantically, you mentally you can think about the same way. But that node is a piece of control flow, and I just jump to it based on my normal control flow if I'm going to start unwinding. So the generated running code, if he decides he's going to unwind, he has to have a runtime test that said, and here I failed something, and I just have to explode. So the return from the open call says fail, and now I'm going to
Well,
throw.
the way I'm looking at this though is that like, okay, if I go up back to this block, right? So this is basically going to be like, we have our foo struct that's parameter one, like
Okay, so
arg1,
where are you?
back
Getting
to
the
top one.
shared code. Okay.
That's like arg1, and then we'll say, I don't know, 2 equals get element pointer, and we're going to say like arg1 plus offset x, and then it'll be like 2 or 3
Yeah.
equals get element
Right.
ptr
Yeah, I call
arg1
them
plus,
field, and I have the same thing. There's a base, which is your struct, and I have an offset for X and Y. Yeah, yeah, yeah.
right?
Okay.
And then it's going to be like, okay, that's because this is going to come from like, so here's the entry, and then
Yeah.
this is going to come from the struct
Come
delegate
from your
new.
new. You have a new for that guy.
Yeah, it's not actually creating it's not like a memory allocation, right? It's a delegation. but it's a new delegation. So
Well,
that's
okay,
why
so
there's
delegation means nothing to me. So use a different word.
it. It
It's
it
so
means
overloaded that it has no meaning. Everyone has a different meaning for delegate. So
what
use a different word here.
it means take the values like the fields of a struct that are in memory and then treat them as if they were on the stack in a way. That's basically what it means. It's
Okay, so
like
you're making a value object, which you can put on the stack or in registers, and you're filling in X and Y into that value object.
right. So it's
Kind of
basically
a
saying
stack object.
start tracking. It's like pretend these are local values so that you can track their lifetimes if you need to do unwinding. That's all it really does. It's like it's basically creating pointers instead of locals, but because they're delegates, they're not actually local. They're actually
Yeah, you
like
have to use the
in
word
memory
delegate again.
somewhere. Well, the word delegate is like it's a delegate of the struct. So like delegate constructors, if you're familiar with C++, where you delegate like subconstruction of
Yeah,
subobjects.
yeah. I'm trying to get you to not use the word delegate. Describe delegate without using the word delegate. That's a cyclic definition. But
Okay,
I
so
think I get what you're saying. In my head, I'm going to try to repeat your words here without using the word delegate. There is a value object, mathematical value object. It has no memory identity. Because it has no memory identity, you can't get a pointer to it that's unique amongst all other pointers on the planet. If you implement that as it's on the stack, I might have a stack pointer relative offset, but I can implement it by putting it in registers, and there is no register pointer. I'm just referring to it in the register. So did I get that right when you do what you mean when you say I have this struct I'm making?
okay, so like this. So like imagine
Yeah,
this
okay,
is kind of the
we're
codec
talking
extension.
past each other again.
So
Uh,
so so so
Does your struct have a unique memory identity that no other struct on the planet in the future or the past will ever have?
maybe sort of like optimization wise potentially, but not as like a like if it's a fully like if it's a local, right? Which we don't know when we enter the constructor because we don't know where the storage was allocated because we're assuming the storage is already here when
Okay,
we enter
so
the constructor.
you've already said I have storage and I have storage allocation. And now, so you're thinking memory, and then is this thing, the storage allocation could be stack, which obviously the identity, well, the identity is while the thing has lifetime. And as soon as the stack unwinds and the life ends, the identity goes away. I'm trying to
Right.
come up with, you do a heap allocation,
We don't
and,
know.
and I can go compare this to another foo struct, and guarantee that they are the same if their pointers are the same and unequal. Guaranteed unequal if the pointers are unequal. Whereas I have
So
a
as long as both of them are alive, you could compare their pointers if you want. But if they're not alive, then you can't do that
yeah, so
because
the
like
pointer goes stale if it's stack allocated or if I free it from the malloc heap.
right, like if it's free, like
You,
it may or
you
may not
are
be
in
useful
fact
because
expecting
So,
to allocate here.
but the answer in general is yes, then, because conservatively you have to assume that there is an identity.
well, the allocation would happen before we enter this function. Like I would allocate on a heap, or I would allocate on a stack space for the foo struct. So I would
Right.
allocate storage and then call the constructor. I don't like I'm not allocating space inside the constructor. The constructor, in order to enter the constructor, the storage has to already be there for you.
Right. Okay. So the constructor, in your head, a constructor says, I have some storage and I'm now filling it in.
Right.
As
And
opposed to I'm making an object and I don't tell you where it comes from or where it goes. I'm making a virtual object, lives entirely in registers, perhaps.
it
Um,
might live entirely in registers. Like the constructor could operate on registers. Like if it
uh,
fits, you know.
the code for the constructor had better know if it's writing to registers or writing to memory. So the code for the constructor has to choose something about
Well,
which way it goes here.
it's writing to a slot, and whether that is memory or not depends on later
Okay.
optimizations.
Okay. So you're having a structure, which is totally reasonable, is to say that I have someplace I'm going to put this. I'm going to declare it at the level of defining the IR as I'm not I don't know if it's memory or it's registers. So that's why I'm calling it a slot. It could be memory, it could be registers.
Correct.
I'm filling it in, and I'll figure it out later,
Right.
as opposed
Um,
to
I mean, really, it's probably memory, but then it could be optimized into a register very easily. with some exceptions. Like
Okay, so yeah, I'm avoiding the as if optimizing. Like when I do these constructors in my head, there was memory. I'm going to fill it in memory. Now, escape analysis lifts it to registers and removes the allocation. Okay, it does. That's a compiler optimization. Semantically, at the IR level, the first step is it's actually in memory. There's another version of this which says semantically, it's a value and there's no memory made, although it might be a giant value that can only ever be in memory, really. But it's a value
yeah,
has no unique pointer to it. At some future date, I give it a unique pointer or I don't if I'm tracking the lifetime myself. If I'm in a language like
yeah,
Python or R and I make some giant array that I'm only ever using locally, no one ever sees it, and it disappears at the end of something and I can't get a pointer to it, no one
yeah.
knows, no one cares.
It's a little tricky because the slot to is this in memory or is this in a register doesn't really
Right,
like
right. You have
translate
this, and then
well.
you have this third version which says, I know I'm talking about slots, and I don't know if it's in memory or registers. Actually, I would call that the value version, except I wouldn't use any pointers. I just say I have a value. And
Yeah.
then as you come into the generating code for the constructor, somebody's going to tell the constructor, you need to be the one that does, stores and loads to memory, and here's an address.
Right. So this IR is not getting directly lowered to machine code. So the main purpose of this IR was so that I had multiple backends. So like I wanted to be able to target both JVM and LLVM as backends.
Ah,
So this IR is kind of like the common intermediary. And what actually happens to like how it gets represented would be a second pass through this.
okay.
So we don't really like I could talk about the semantics of slots, but like the idea is basically that this is just a common representation for the sort of the compiled code before we know whether we're targeting LLVM or we're targeting JVM or I'm targeting, I don't know, some maybe I handwrite a lowering pass myself at some point.
Okay.
That's kind of the
Yeah, I'm kind of going back and forth. You still look like you're thinking hard about there is a pointer that the,
right.
constructor gets passed.
This is supposed to be like the LLVM version. I don't know what the Java version exactly is going to look like yet. But like this, I am optimizing kind of the design of the IR to simplify the generation of LLV because like I at first I was kind of directly generating IR that didn't have the like locals and like what I found was that without these like slots like the code generation complexity of handling like the unwind generation in the IR was like very significantly hard. And so like the slot was like mostly to handle C++'s unwinding table behavior because this language has the same sort of thing in a way that didn't make my code generation explode by like tracking it implicitly so that I'm not creating like 20 different IR paths for the unwind table when 99% of the time you don't throw an exception and you only care about one path, which is not the like the non-exception path.
Yeah, I claim I got there, but a completely different way, and I exposed all the IR, and that worked for me. But I
So
wasn't
the
doing C++
goal of this
exceptions,
IR
so I don't
is
know.
not to produce machine code, but to produce either
Yep.
JVM byte code
Yeah,
or LLVM bit code.
yeah, you're a long
Yeah,
ways from JVM bytecodes here because you have already lowered past the point where the JVM is talking about doing field things. Like you're gonna have to lift this back up to JVM bytecodes. You're below JVM bytecodes, and that will be
Yeah, that was going to be
tough.
sort of my question. Why is this as low level as it is if those are the targets?
Yeah.
Could this whole thing be a higher level?
I'll have to figure out maybe. So it definitely can translate to LLVM. I don't know 100% on
Yeah,
JVM.
you
That's
you
kind of
would
like
have
a
trouble.
stretch goal.
Yeah, as soon as you do any optimizations where you lose, like you could unwind your tiny example to JVM bytecodes by some pattern matching, but as soon as you do any internal optimizations or changing of how things go, you will not be able to turn that into bytecodes directly, and then you get a horrible bad bytecode, like a translation that involves way extra work. The usual story of translations. If you lose the semantics of one of the language you're trying to go to, you have a horrible, totally generic translation mechanism that's extremely expensive.
Right.
And
So
if you
so
keep the
the
semantics, you have a direct, straightforward thing.
Yeah, what I
yeah,
can't do in my head is guess how well it's going to get cleaned up by the optimizer.
so
Like
this should
sometimes you can do
be
these sort of template stamping things that you accomplish your low-level assembly-like things by using large chunks of JavaScript. But
So
then
this
JavaScript
is
interpreter does actually compile it down nicely.
this is actually super optimizable in LLVM because this is still SSA. It's like taking the address of arg1, so it's like you pass it by
Yeah.
address, right? And then you take the
It,
address of arg.
it's super optimizable in C2. It's not super writable in Java bytecodes, or it's close to not being writable in Java
Yeah.
bytecodes.
So I guess
Because this sequence here, this %2 is not a thing that you can talk about in Java.
right, it's all
Uh,
stack based. I know. I have to
okay.
figure some of that stuff out.
So
Like
if you
this is the LLVM version. This is what I like.
okay.
Here's the instruction in my IR, and here's what I think it'll look like in
So
LLVM.
here is a thing you can say in Java. You can say, I have a foo.x type
Right.
thing, right? And I don't get this is an L value, and it's the type of the base and the field taken together, and you can't break them apart. So you don't have plus offset X. You just have to say X. And the optimizer will figure out what the offset's going to be, and the base pointer comes from here. So you're actually of type this. Your value is this of class, or this is of class foo. But those two have to stay together. And then now that you have that, then you can do loads and stores with this.x. There's a
Yeah.
store opcode that takes a this.x and
Yeah,
a
so that would be like you could retrieve that from here. So if I say I'm delegating on one, I know it's a foo struct, and then I know that number two is x because it's a x equals number two. So therefore, I would be able to get to this from the struct delegate new
I'm
because I'd
saying
pass the fields in here.
if you ever break this apart or fold it up somehow, you won't be able to get to here.
This is not this is LLVM. Like get element
Yeah,
pointer is
I
an LLVM
understand that. I'm
function.
trying to help you with the Java version. The reason that'll show up is down here at the store op, there is no take a generic pointer and store 7. There's no generic pointer like %2, pointing to an element in the middle. This is only going to be done as a this.x equals 7 or equals your immediate, whatever. So you have to
Okay.
have the pair, the base and the offset always kept together. You never talk about a pointer into the middle of an object. You only talk about the base and the offset.
Yeah, that actually does comport a little bit with the like access field instruction. I would just have to kind of trace which field it came from as part of the type when I'm
Yeah, I'm just saying, if you
or
break it apart and then you do fancy optimizations with the arg1 and the offsets, and then you try to reassemble it, you won't know. Like you can't have a generic, I pick either X or Y in the same pointer. So here's an unrelated thing here where I say auto pointer is random of this dot X and this dot Y. We'll make this the address, so it makes it a little more easy. And then somewhere down below here, I'm going to say, oh, point equals 7. Like you can't write that in Java.
I mean you can, you just have to create objects that contain an int and then use the
Well, so you do
object
the
instead.
completely generic thing, which is the incredibly expensive. I just make a few objects to do a simple assignment. No. So that then you blow out your
Yeah,
straightforward
yeah,
translation and you get it.
I'm
Yeah.
aware. The Java version
Okay.
was not is like I just want that to make it so that it could hypothetically be portable, not so that it could be efficient.
Can't you pass L values deep into objects around in Java?
Yeah, you can't do
I,
it directly. You do it
I mean,
indirectly.
I actually don't know if is it that you can't do it in the Java bytecode or you can't do
You
it in Java at all? Because that's
can't do it in the
actually really
Java
my target.
bytecodes. Well, it's all things are Turing complete. So you can always screw around. So I'm making you an L value here, which is going to be a new L value, and he's going to take a this and an enum of X. Pick one of X or Y. So I'll make a pair, which is the base pointer and an indicator of the field. Now I can store and load and read and write L values here by in Java just directly exploding that out into switch on the enum and I picked you X or picked you Y. And that would basically, be completely generic and really bad performance. Every L value write would start with big switch. Which field are you talking about at runtime?
Yeah.
I
So
mean, it's a distinction between creating language that runs uh, on the JVM and creating a language that implements its own runtime in the
Yeah,
JVM, and
yeah.
that basically also means or that decides whether your interop between your host
Yeah.
language and your own language will be seamless or will require helper methods and translation
Right.
layers
And
and stuff.
those will stack up cost. So there is a real reason for this, and that is interior pointers screw with garbage collectors. So Java has no interior pointers.
Okay, so I'll have to worry about that a lot later. I'm not
Okay,
worried about it
fine.
quite yet.
Right. I'm
Right.
fine with an L value being a fat pointer that is a pointer to the base of the whole object and then some indicator as to which field you're talking
Yeah,
about.
right. For an
But I
array, of
don't
course,
see
it's
why
easy.
that is inherently going to be so slow to pass around these fat pointer L value objects.
If your optimizer is clever to put this as a pair and pass it in a pair of registers, then the cost isn't huge. The the other thing the optimizer that Java doesn't, the JVM doesn't understand, the optimizer could, is that the offset is being passed along with the base. And so instead of an enum, I would have +4 or +8 or whatever the offset is. And then the generated code is pretty easy. It's reg plus reg.
Right. I
And
mean,
you
it's a
could,
little bit awkward from a garbage collection standpoint because you're keeping the whole object alive because you have a reference to one piece of it.
no, no, that's the good answer. Yes, you're keeping the whole object alive. We're not doing partial object dead clean out from the garbage collector. But the garbage collector starts with, I have a base pointer. And oh, and some ints over here that I don't care about. Oh, I have a base pointer. Yay, I'm how happy. As opposed to, I have a random pointer. Where's the base? So I can ask questions about lifetime and management and poke the base object and say the whole object's alive or not or whatever. So the garbage collector has real issues if you can't find the base.
Yeah, I think if I were writing a language today, I would use fat pointery things
Yeah,
for L values, but I would also probably want those L values to be a first class feature of the language and a thing that you could pass around and a thing that the
yeah.
garbage collector was designed knowing about and optimizer was designed knowing about.
It's the
It's just such a
optimizer.
useful thing to be able to pass around a
Right.
reference to the middle of an object.
Yeah, it's the optimizer has to deal. I went down this path. I said base and offset as a fat thing and then just let the language know about it. And so it's easy to
I would even
optimize
use
it.
that
Right.
syntax of ampersand this dot x. Yeah.
So I guess the real kind of question though is like I could see that this like optimizes super well, right? If I generate this LLVM code, this like basically folds and inlines and everything, right?
Right. You don't have the
With
example where something fails and you have a fail handler.
right, but that doesn't even get like that's just those are unwind tables. Those are pretty simple with
No,
LLVM.
no, but they totally screw with you because you picked only ints which can't fail. So you
That's
picked
true.
something here that can fail. Now you have an unwind table marker in the middle of your block that says, I have to do things above this line or below this line, but I can't cross the line because if I cross the line, then I have to go to the unwind and I throw an exception. I have to go to the unwind piece, which can observe things before the exception and not afterwards, and vice versa.
Yeah, it's still like well, if it's still like the optimizer sees you do something that can't throw an exception, it's not going to create the unwind operation.
No,
So
no, no.
like
I'm saying throw down a thing that is visible, globally visible, then throw down a thing that has an exception, throw down another globally visible update. You can't schedule across the unwind boundary for everyone who's going to fail. And in my world, what I said was there's an if that says it failed, and your semantics are you did operations before or after. Same as every load and store operation on the planet is ordered, those were ordered as well. And the normal ordering, there's no special, it's an unwind ordering only or anything like that. It's just
right. So like if we
ordered.
do I don't know we do something like this like let me go up here actually. So let's say I have I'm going back up to the first example.
What's
So I
IDK?
invoke.
Okay. So
So
you're
it's like
calling it another constructor.
yeah, so we call the bar.constructor. We say this
Yeah.
equals two. Other like this is like that's the extent of exception handling in the IR is like I want to invoke this function,
Yeah.
and then if it throws, it knows that oh this object was alive or that object was alive, so therefore I need to call those. So like it
Yeah.
it simplifies the generation of this IR because I don't have to write if invoke failed inside the IR. It's just
I,
implicit.
I, I
Like
don't
if the
I
invoke
don't
fails,
yeah, I
run the
don't either.
destructor.
For me, a call, like a bar.constructor inline call there that you wrote in the line, is a hard stop. It's a safe point. Things that have updates, like the optimizer can't peek into bar constructor without inlining it. So he doesn't know what it does. So he has to assume it reads everything and writes everything because that's what a standard call could do. And it can throw.
Right.
So things that have to be written before the constructor are forced to using standard memory edge. Things that afterwards have to because standard memory edges. And I don't have any special IR. And I don't have an if in there that says unwind or anything either. I don't need one.
Okay, so I guess they're similar then. So anyway, um, I guess where I was kind of wanting to get at this was more of the array thing, because this struct delegate new, right? And you see that I have assigned a slot for every element of the
Yeah.
struct.
Yeah. What do you do with arrays?
And if the array has four things, you could kind of like, I guess you could get the same kind of thing. Like you could say, you know what, 0 equals
Right.
1.
Yeah.
Uh,
It,
you know,
so,
1
so
equals
get away from the constant size because
2.
that's the easy case. You
Well, it's
read
always got to be a
read
comments.
this. Yeah, you read the array size from the command line, and it's an unknown size in. So
Right.
unrolling the array contents so I can have initializing
Well, yeah, no, you
four
can't do that
elements.
actually. You can't. All arrays are fixed size, like C++. But
No, it's C++.
the problem,
They're fixed but unknown.
no, they can't be unknown
Yeah, they
compiled.
are. I'm confused.
No, that would be like a memory allocation, and then you do
No,
like
no, but you don't do
vector.
that. You wrote 40,000. So replace 40,000
Yeah,
with in.
you can't do that. That's not a
I
type.
can in every C program on the planet, and they all do. In equals read.
Variable, like, okay, so that's like a pointer, which is one type, plus a count. It's not
Every
actually an array type.
I'm trying to make an array. I'm trying to make a network buffer.
Like if you say like int n equals food, that's just the case to a pointer. Like this is not really an array. Do you understand what I'm saying? Like it's not actually an array, it's a
No, no, but
pointer.
I'm now going to malloc an array
But
of
you're not
size.
allocating an array. You're creating a pointer. Like the
Yeah, yeah,
result of
I
malloc is a
understand that.
pointer. It's not an array.
I
Like
understand.
I know it's a pointer to an array, but like it's
Yeah.
not typed as an array.
Okay, Ryan, I understand that. Show the code where you create the array, not the
So
one where you get a pointer to it. Create the array.
so that's kind of like, here's the thing. Like let's say I could do this struct delegate new thing that I do with structs. The problem is not when there's four elements, right? Because like if there are four, we could
Uh-huh.
do the exact same thing as we do up here.
Yeah.
What happens when there's 40,000? Do I
The same.
have
Okay, wait, back up.
40,000
But back,
instructions, right?
Ryan, you're charging ahead. Back up. Replace 40,000 within an unknown runtime value. It's
You cannot do that. You cannot construct a dynamic
everyone
array.
on the planet does it. What are you talking about?
It's a class. It's not a primitive type. Dynamic arrays are not
Okay,
primitive.
so you're
But
defining a new thing, which is I don't understand why it has to only be constants. Like no one will write code where you only have arrays that
But
are known compile
they
time.
exist, but they are not primitive types. They are not a primitive type. So you
but
can't
somehow you have to implement them, and I
Yeah,
guess that's the question, right?
like,
Somewhere
yeah,
you have to have a way to allocate a variable amount of money that
right.
you don't know at
The
compile time.
the IR has no concept of a dynamically sized array because you need to call the memory allocator, and the IR is too low level for that. So you would have to like create a class, and then inside the class constructor, you would be like data equals malloc blah blah blah, right? That's not part of
okay,
the
so
built-in
it's not
IR.
part of your language's definition of what it means. I'm still confused here. Like your language doesn't allow me to go make an array whose size is the size of the file I'm looking. Like first thing you do, stat the file. Oh, its size 40,000, whatever it is. Okay,
Right. It
make
wouldn't
an array
be
of size 40,000, read the file into the buffer.
like you could create dynamic array of
Uh-huh.
int x equals file.read, but you cannot create like n int. Like this is not a type. You could have std dynamic array int, like, or like it's like how Java has like array list, right? Like you could create an array list of int, but you can't create an array if n
Yeah, but even
where where
No, you can.
that
You
array list
really can in
underneath
Java.
allocates an array of a
no,
variable amount of
right, but this
length.
array list is like the n is not part of the type. It's a runtime
That's
value.
correct. And in is
So
still not part of the type, but I want an array that I'm going to make that's
that would be
dynamically
a class.
sized
Like
that
you would
clearly
implement that in a class. You can't like the IR does not have
you,
like
your
you
IR,
would
you say the IR, your IR does not
yeah
have a way to just say malloc a malloc a random number.
you can't malloc that's like call. You could like evoke a foreign function call, and that happens to be malloc or something. You don't have
Why not? Why do you not allow people to have variable sized arrays in the language spec? In your language spec,
um
you have them in C and Java. Why are you not allowing them in
what's
language?
C doesn't technically what's like if I create one in C, like I say um x, if I have a parameter that's like int x like this,
Yeah,
it's a pointer in C. It's not actually an array.
yeah, I understand. Go allocate an array in C, which everyone on the planet does.
Right, but
And then
this
they
is
have a
this is
thing
the
which is an
actual type in C is not like the
yeah,
the type is not actually an array. Like this is syntax sugar for a pointer. It's not an
right,
array.
right. I get it. So you get back from malloc a pointer to what you happen to know to be an array. And from C's point of view, it's just a pointer. Java keeps the arrayness, but doesn't know anything about the size. So Java says I have an int array of unknown size, and the size is not part of the spec for the or the type for an array.
Right.
That seems pretty straightforward.
Yeah.
But
I'm multitasking, so I think I might have misunderstood something, but it sounds like the language specs are tied to the IR specs, and I have no idea why, and that doesn't seem necessary.
No,
so like
the Java version, the tie is I want to have variable sized arrays, so the size of the array is not part of the type. And
so
therefore, the language says I
So
have an array type, but
I think it's
type.
kind of, I thought it's not an example of compiler explorer, but I think it's kind of like even in C, you have VLAs, right? Which are variable length arrays, and they can be sized by some int n, which is a runtime value, and you would just allocate on the stack. So that's fine. But the way it's
tech
represented in LLVM IR, it's gonna be just an alloca, and alloca returns a pointer to the stack slot. So I think his IR is similar to LLVM IR, is that his IR doesn't have the notion of symbolically sized arrays. Even though you could track this n, and you could have a notion of n-sized array, I don't think his IR does it, from what I
Yeah,
understood.
and Java does not either. I'm not suggesting that that's a reasonable thing to do. I'm wondering how I would get why you keep saying I want an array of size 40, like 40,000 you can't unroll forever.
right.
But no,
So
that's fine.
so
But
the
instead
the
of constants, go in. You still can't unroll forever. Same
so
problem you
so I
have.
guess
You
what
can't
I was
unroll.
actually kind of going here is like now we have array array init new, right? And I'm probably gonna change the name of the struct one to be like struct init new or something. But then the way that this would work is instead of creating like a slot for each field, you create a slot of type like array initializer of 40,000 foo struct. And then this you can on this array initializer, you can say array init element of 2 is equal to that you can like create a slot here and set foo struct, and this is like foo struct. So kind of here's I guess where you're trying to get at. You can then call you know foo struct dot constructor, and then I don't know your parameters here, and then you can say array init remaining or something to and say 4 and so you can say bool is there more, and then you can
Why?
do branch
Aren't you just in,
for and then I don't know
aren't you just in a loop here?
what. So you now you have like a loop. Actually, this hang on. We need a new
Let's say this
block.
is like an obvious thing here is you're going to go work your way through a loop and init the
Right.
thing. And the array is partially initialized throughout its life, through its initializer here. So some elements are random crap and some elements are foo structs. And it's a
Right.
moving wave. This is very straightforward, very obvious. And now is your complaint, I don't like it because
Okay, so this
Don't
is
show us the unwound loop. Just say for all the elements in the array, do something. It's clear you have a partially initialized array for much of the life here.
yeah. So basically, kind of does this sort of. I mean, this IR is wrong, but like it's so my idea is like there could be an array initializer which tracks like dynamically how many elements it has constructed.
Yeah.
It's still not dynamic in the sense that if it's an array initializer for 40,000 n, but it's like a runtime of how many have been constructed so far. But
Right.
you still have to say like I am an initializer for an array of type 40,000 because there's no like dynamically sized array.
I would claim that I do this in C and Java all the time, that you just have an array of size n and you're going to initialize it and it's for I
Well, C
whatever.
doesn't have destructors, right? So the C is irrelevant for that discussion, right? The
Okay, C++.
analogy here is
That's fine for C++ too here.
well, C++
And of course,
like standard array doesn't have a
this
like
isn't like I'm not talking standard array. I'm just making an array and I'm going to run through it and I'm trying to initialize a 40,000 foos. And at 27,000 foo number, I throw an exception. And now what's the destructor?
I don't even know what happens in C++. Hang on. I'm actually curious what C++ does here.
I don't know. Is
It's
this
just
like for your language is whatever you want for the semantics? Like suppose I open 40,000 files and then I run out of file handlers and the OS blows on me. I don't want to unwind the throw. I mean, sorry, the destructor conceptually might want to walk backwards through the 40,000 and in reverse order, run the destructor, which would close the previous 27,000 files that successfully opened, and then get out and say, okay, I failed to make this array of 40,000 files. I think that's like a reasonable use case here of destructors and constructors on an array of 40,000.
okay, so let me try. Let's see. I'm gonna have
I don't understand why. Still makes sense that you have to have 40,000 as a type.
okay, what does this do?
So the Cameron, who's not here, comes around with XTX. Other people have done this too, actually. So for arrays specifically, um, people have experimented with putting a lambda for each element as a constructor that you would for loop your way through. That you say, make me a new array of size n with this following lambda that would fill the initial values. And then it hides from the outside world the half initialized array. You either get it completely initialized or you failed in the middle and the whole construction failed. And that sort of solves the problem of having a half initialized array when you begin exploding and you have to unwind. And it contains who does the unwind? It's the constructor method that deals with taking a lambda, and he can run the array in reverse and run the destructors in reverse and unwind, sort of perfectly unwind.
Okay, so C++, I'm not really sure what it's doing here, but it has a similar kind of thing.
I think C++ says you have to have a no arg constructor for an array of things, and the no arg constructor bakes down to a particular memory pattern, and he just bulk fills with the memory pattern.
Here, let me grab the
Throw an
link
exception
here.
then.
I just gotta I'll put this above the block right there. So the gobble link.
I think we're getting pretty messy here.
Yeah, so this is above.
I'm multitasking, so I wasn't 100% paying attention. But if you use the curly braces when you initialize a variable, it will zero fill it. But if there's a default constructor, I think it uses the default constructor.
It uses the default, right? For an array, then the question is for an array of size n with a foo struct which has a default constructor which is not all zeros. What does C++ do? Does he build a default constructor which turns into some small, I set some bits, I set a 1 and a 2 or whatever, and then he
All right,
mem copies it to
yeah.
blast the array fill.
So if you scroll up, you can see what C++ is doing here. So it looks like it is.
I don't know where you want me to scroll to.
Scroll up until you find it. It's at
So
the
what?
top of the block.
Yeah, I scrolled up until I didn't find
The
it.
second link.
Oh, is it down?
The second link.
Second link?
Yeah, into the link section.
Oh, you mean go
Oh,
to
someone moved
Godbolt?
it. Oh, someone
Yeah,
moved it. Yeah, that's
I
dumb.
moved it. Yeah.
Okay,
Okay.
no one told me Godbolt.
Yeah. Yeah. So
This
you can see
is okay.
C++
Yes.
does some like tracking of how many elements it's initialized, and then it after like it creates that you can see that it's like, okay, I'm initializing after 10 of them, I go back and I start uninitializing them. So that's kind of like what my array initializer would do,
Mm.
is it counts how many like elements
Yeah.
it has initialized, and then
Yeah.
if it throws, then it's going to go start undoing those constructors. And this was like my idea of doing this with a runtime value. Instead of doing this with like individual pointers for each struct field. And I'm just wondering, like, what kind of optimization concerns are there around doing it with a runtime value like this, and like how often, like especially
It tracks how many elements are initialized,
think
so it can
yeah.
deinitialize in
I think
uninitialize.
he
Yeah.
comes through here and says, I have an exception when I hit my, here I got to line 14. Sorry, I compared to 10 up here. I got my exception throw. I go to 14 where I build the exception. Then I set up for the loop. Here's the loop where he runs through and he is doing a -1 on bar for each trip around while he's trying to count down to 8. Wow, he's actually optimized it fairly well. So he's unwinding one at a time. I mean, this loop here, you could just say, well, wait a second, I'm just going to unwind down to whatever R8 is, and why am I doing it -1 until I hit R8? Fine. But he has an unwind loop. So that is to say, this implicitly has a for loop where he calls the constructor, which does bar and test, and then eventually throws. So there's a hot loop where he fills up bars till he hits the 10, then a hot loop, this one, where he fills up negate foo and that decrements bar. So it's kind of, I mean, that was what we were just talking about a second ago. This is how you would do it.
What if the number is large? The X is 2,000, 20,000?
That's the reason why I was thinking of using this array initializer, because what I was thinking of doing originally was like struct delegate new, but then I have 40,000 elements, and then I have 40,000 slots in my IR, and I'm like,
Yeah.
this is dumb.
Is
You
it
don't want to do that.
possible? Is it possible to chain each initializer in a linked list? So the first point to the second to the third, and if you call the 1,000, it start calling back.
So the initializer
list
is a like a pseudo type. It's not actually a type, but it's like it's kind of it would create an object at runtime, but it's not like a type in the language, I guess, because it's like hidden inside the implementation of the constructor.
Did you get what I tried to say?
Yeah,
I didn't get a chance to hear. Let Tidor finish.
I think, is it possible to chain the uninitializers or the destructors inside the next object? So the first point to the destruction of the second, and if you call the last one, it will start calling back in a linked list like fashion. It will deallocate
you could do that, but that would be a little bit less efficient than this, because
but you don't have to track how many objects are you initializing.
I think the language semantics for C++ here are saying, I'm going to count how many of these foos until I throw, and I know the number. Although it's not written in the code, I've counted how many when I threw. Given that count, I know how many twiddle foos to call.
But if you don't know if it's a runtime determined,
no, the runtime. Yes, that's exactly. So replace 20 with n, and the bar here with random. I don't know where I'm going to throw, so he's going to count. What you don't see here is the compiler has inserted a for loop to call the foo constructor for the length of this array, which happens to be 20 here, but could be n. That's this loop here.
Right. Yeah, and the only reason why I don't have dynamically sized arrays as a primitive type is because every object is a fixed size. And like dynamically sized arrays as a primitive type break that. So if something is a dynamically sized object, it needs to come from a memory allocation on the heap. That's the reason why I don't support dynamically sized arrays for that reason, not because like the initializer logic wouldn't work.
Okay, so let me go back with Theodore for just a second here. Did you understand what I said, Theodore? There's a counting done here. He knows when he throws what the trip count is.
It's when it starts, it counts how many objects has been initialized until it throws. Is that correct?
Yeah, and I don't know sure which count it is, but here's a 19 and here's a -1 on RBX. So he's counting down here
Yeah.
and he's counting up here until he explodes. This is bar being optimized. So he knows RBX when he throws.
Mm.
When he comes down to here, he's probably shuffled things around. Here's RBX being mathed against AX against 19. This looks like how many did I fail on? Okay, I have this as may need to unwind. And
So
then he moves something here to go do the math to unwind. I'm not sure. This very strange loop. Or he fails to optimize it because he knows it's an exception, therefore it's not important to be efficient here.
I
So
think it's because I put 01. It was different when I did 02 or 03. I just wanted to make it like more obviously closer to the
gotcha.
original.
Gotcha. Oh, we're in 01. Yeah, fine. Yeah, yeah. Yeah, yeah. This
I,
loop could be cleaned up, but I don't care. And you don't care. Right, right.
I
Yeah, I
actually,
think the language runtime semantics count trips through the loop or through the array, and when you blow in the middle, who counts unwinds. This is not a thing Java does.
yeah. So I guess there's like, my thought is like, do I go for this array initializer like 100% of the time? Let's say I have 4 elements. Do I still use this like this
Oh,
counter when there's 4 elements, or do I say, hey, there's only 8 in this array? Do
no,
I then
no,
say,
the 4 and the 8 are red herrings. You should get your semantics working, and then it's an optimization question. But optimization waits until first you have a language working and code written, and you see how many times it's 4 or versus 40,000.
okay. So I mean, the struct delegate new I already have working. I'm working on the array thing to like because I don't
You
want to
handle
have.
the 40, you handle the generic worst case scenario always. That says I can use the language without hitting a funny limitation of 40,000 or 4. So you handle the biggest case, and then there's an optimization to be done on the smaller case.
I guess I like what I really wanted to talk about was like, okay,
Don't put
are
40,000.
there
Yeah, yeah,
are
don't put
there
40,000 slots out.
are there optimization reasons why like I should unroll this like ahead of time on the like say there's only
No,
8 elements? Like
no,
should
no.
I avoid branching and say like, okay, if I know exactly how many elements there are and it's not, a big number, should I
Right.
put in
This
a
is
threshold
okay.
and unwind it in one block?
You see in front of you a thing you can easily optimize, but you have many such things you could easily optimize going down the road. You solve for the generic case, solve for an unroller that has enough intelligence to decide to unroll the 4 case because it's a constant size. He says, I'm going to count 4. I have a couple options in the block 1 that I've highlighted there. Its trip count is 4, therefore perfect candidate for unrolling. But don't think about it while you're parsing and building IR. Just throughout the generic case. 4 or
Okay.
40,000 same code. Flat. Okay, now the optimizer comes along later and says, oh, it's 4. Let me unroll.
Right. But I mean like my optimizer is translate this to LLVM IR and
Yeah,
then run LLVM's optimizer. So
right. And
my thought
LLVM
is
will
like,
say, trip count 4, piece of cake, unroll.
so what if the like what I'm thinking about here is like let's say I have to like create this object in memory that stores the count, right? So the count is like I've created
Yeah.
4 objects. Can I apply it like let's say inside one of
No, no.
these
In the
it,
40,000 case, you didn't make 4 objects, and you didn't make
right,
40,000.
okay. But let's say I don't know, it's just n. Okay.
No, no.
Discard
I'm saying solve for the worst case. And that is what you're feeding LLVM. What is
right.
the worst case? It's some giant ass number.
Right, but I'm thinking like let's say I have a constructor that in somewhere inside the constructor writes an int or reads int from memory. If I'm storing like a dynamic counter, is the aliasing analysis like can I get the aliasing analysis like can I hint it strongly enough
You
that
better. Surely, yes. This is LLVM. It should be good at this.
yeah,
You're
I'm just
saying, is the trip counter known to be independent of other things? And the answer is
essentially yeah.
surely you can make it so.
I'm just wondering, like, is there going to be a situation where LLVM is not going to figure out, oh, this size is like completely independent, and therefore, like, hoisting it into a struct initialization would be more optimal because it's not smart enough to like optimize it.
I claim I would first generate and get it functional and then look at what LLVM is failing on. And it will surely fail somewhere. It seems unlikely to me that it fails here, but you will have LLVM failures to deal with. And if this is the one, then you can go in and make it smarter. But I don't think you'll have any, I don't think this will be the trouble.
So I should just go with the array initializer for everything and
Yeah.
then
Yeah.
worry about it after I'm generating
Right.
machine code. And
Right. And look at the machine code and say, LLVM, you should have inlined and you didn't. You should have unrolled and you didn't. Why not? And then sort it out then. But you'll have a lot of those, and it won't necessarily be here. So don't micro optimize this case. Get it all going end to end. Come back around. Hey, this is a classic. The root of all evil is whatever premature optimization. Just get it working.
okay. So do you think that for like doing this unrolling, like array init, and then we hit like array init new, you have array init value, and then you have that like takes the value and gets your, thing you can use to construct it. And then you have array init more or remaining, which is like how many are left, or if you could do a bool and be like, is there any left or not, if you're just like doing one at a time. And then you can also have just array init complete, which just closes off the constructor.
You want to write a loop that is as canonical as possible from LLVM's point of view. It should look as most loopy-like as possible, and that would be the most likely that he'll figure out, it's a loop, and here's the induction variable, and here's the counter, and it's the trip counts because it came from 40,000 or 4, and I'm going to unroll or not. Write the easiest possible loop that you think LLVM will understand. And I don't know enough LLVM IR to say what that loop looks like.
Okay, so I'll try that then. And I'm thinking like these four, like I have like array init has four instructions. There's new, there's value, there's remaining, which is like get a count, and
Yeah,
then
see,
there's
remaining's not part of the array init in my head. It's just a variable. You just need to pick a variable. You have a length, which is 40,000 or whatever your constant is. And you have a trip counter. 1, 2, 3, 4, 5, 6. I guess 0, 1, 2, 3,
right.
4.
Well, like the count of the remaining elements is stored inside the initializer, because the initializer is also what triggers the unwinding. Like, so the initializer stores the count of how many you've
Right, but it doesn't need a
created.
special opcode. It's just a variable. It's just an int.
Well, no, because then if it's not a special type, then when I like throw an exception, if it's just an int, it's not going to trigger an unwinding of the values inside the array
Why
because
not?
because there's no value to unwind. Because like the things that get unwound are the things that are in slots.
Okay, so
So if there's no slot for all those 40,000 values, it's not going to get
so you
unwound.
have a semantic that says somewhere that I have a partially completed array as a value and a partially uncompleted array as a value or something. I'm kind of confused here because in my head, the throw from grabbing the next element, which fails because the constructor can't find a function, whatever the fuck it fails for, should jump to a table that said, get the counter for the remaining things and start unwinding from it.
Well,
Like
like
trip count is
when a throw happens, what it's going to do is it's going to say, okay, what objects are alive that are not alive in the parent scope? And then if
so
one
your
of those is
throw
in,
doesn't have the complete state. Like
it
at
has
Java,
this,
when I throw, I have the complete state of every possible variable.
right. So there is a state, right? So there's like each slot has a state, like because like if I'm in the middle of a block, right, and there's a variable number of loop iterations, I don't know like at compile
Yeah.
time.
There is no way. You won't be able to tell because you've got the state implicit in your IR. So there is no way for you to implicitly know this variable that changes through the iterations of the loop.
You're talking about for
This,
LLVM,
yeah.
because Java does this all the time.
For his IR, for his current intermediate, where the states, the constructed states or the non-constructed states are implicitly, stored in the ordering of the IR.
Yeah,
There's no way to do it because you don't have that implicit ordering.
Okay.
So
This is one of those things that Cliff before said, if you just made it explicit, you could do these specializations in these specialized cases because you've got it explicit in the control flow.
Right. I was just thinking, You're already explicit in the control flow, and you're saying, no, it's not what it is. And now I'm seeing it. It's fine. Yep.
So basically, like when let's say you trigger an exception and there is an array initializer that exists, right? That would trigger a special call to like unwind. Like the array initializer would contain
Well,
a runtime value that's how many
it,
elements have already been constructed.
in
And then
in how I would implement this in my IR, the trip counter for the how far I've initialized would be available in the unwinder, who would then just take it and unwind backwards from it.
right. But the reason why the array initializer needs to exist is because if I just put that as like an I32 or something, then it would just call I32.destructor, which does nothing.
No, no,
Right.
no,
So
no.
it's
It's not
so
not
it's
what I'm saying. I'm echoing Ben here. In a different world, not what you're doing, I would have said I would expose the constructor and deconstructor to the IR directly by just inlining the IR for it as explicit control flow. And the for
hmm.
loop would say for 0 do 40,000 do init and if throw at the destructor, I would say, oh, well, I is still available to me. So from I, what is minus minus back down to 0, call the destructors and get out.
So that does happen, but that happens like when I convert this IR to LLVM IR, that's
Yeah.
where that control flow gets introduced because
Okay.
LLVM has that control flow, but what I found is that making it implicit like greatly simplifies the code generation complexity that I was dealing with. And that's the reason why I made it implicit is like it just keeps track of what objects are alive. And if an
Yeah.
object has a destructor, then that's just like
Right.
you have to
Right.
destroy it because it's an object
Your
and it has a
problem here is that you
destructor.
have a half object alive, half of an object, which is why you need the remaining piece because you're going to go find that half
Correct.
typed as a half initialized array, and that's your trigger to say, okay, now start unwinding. But
Right. So
I claim that you're making a workable IR, but it's not the one that I would design.
I'm wondering, well, if see the thing is I think any IR that you design would be for a language that doesn't have like RAI destructors.
No. I have
Like
done so and doing so now, have done in the past. Same. The
it's
success I got out of exposing all this control flow to the optimizer directly as just bulk IR worked so well that I have done this with RAI. It's fine.
I can see why you would want to expose the control flow to the optimizer, but like during the generation, what I want to do is I
Yeah.
want to generate it without the control flow, and then I want to do a second pass that creates the second layer of control
Okay.
flow. And the
I
reason why is it just makes the
it,
generation so much easier.
I hear you, and for me that it's not. It didn't make a difference. The generator bits and pieces for this kind of array, loop and fill, and then unwind is some toolbox boilerplate pieces I snap together. And then at the throw point, there you snap together the other pieces for the unwind, and then it's done. It's no more
So,
code than what you had showed already on your screen, on the screen here. And
so
it
like, do you
doesn't,
have like a array constructor and destructor? Like, I thought Java didn't have those though.
yeah, so this is not for Java. This
Okay.
is for other languages.
Yeah, I'm just
So
Just as a possible
you said
solution,
you wouldn't do this for something with RAI. I totally would. Now, Java has an RAI mechanism, but not for partial arrays. And the
okay.
RAI is very explicit at the Java level, so it's not really the same. Like you don't use it everywhere all the time. But this amount of code is roughly the amount of code I would use to do the RAA wind and unwind. Somewhere in here, I'd have hey, I'm the constructor for loop, and if I throw in the middle, here's the destructor for loop, and they share the same variable, so they can unwind directly. Um, and that's just, IR has two loops, one after another, and however you generate a loop in the IR, and that's some amount of boilerplate, which you're showing here is the same kind of thing. I have similar things for smashing out the boilerplate for IR, for loop IR. So there's a wind and an unwind, and they share the index variable when they start unwinding. Fine.
okay.
Yeah.
Um,
Look, just as a solution, why don't you make a compiler intrinsic class that is in charge of constructing the array? So as you said before,
that that
it's just
is
an
that is what this
int.
is.
Yeah.
No. As you said before, it's just an int. So when it gets unwound, it automatically gets deleted. Promote the int into a class that has a constructor that constructs the other array and a destructor that destructs the other array, because then you can write your own code in its
That's what this
constructor and
is.
destructor.
It's about
Yeah,
to,
that's basically what array initializer is. Like that's why there's a double underscore. Like you can't create an object of type array initializer. Like this is only compiler generated.
and that is
That's
the
why.
initializer object. So internally, it should
Okay.
have the int counter.
And it would also have a pointer to the array because like you could access it one at a time. But yeah,
So why does the initialize? So if you make this object internally, he has the trip count, right?
yes,
The partial
yes,
trip count.
right.
And then so what is this array in remaining? Isn't this
That's like
just like
count how many elements are left to initialize, branch if it's 0 or whatever, and then like that's like
why
am
are you
I
not just invoking the array initializer, do it, and then you'll inline that guy later?
well how do I like the array initializer I mean this is the constructor of the array, so if I have to just invoke the array initializer, I just have the same problem, right? Where I'm calling another constructor that I also have to generate. So it
Well,
doesn't that would just
I'm hypothesizing or theorizing the contents of the array initializer has a construct and a destruct and a common shared state variable, which is the how far I got before I blew out. You have a common shared foo struct array base, common shared max for the size of the number of foo structs, and a common shared here's how far I got before I blew out.
essentially.
And
So
then
array init remaining is like, okay, I want to query this initializer and ask, is there anything left to initialize or am I done?
yeah, but
Or
now
you
I'm
could get the
asking
count.
why is that an opcode as opposed to maybe I don't know. I would, but
I
you're
mean,
exposing the IR. Don't worry about it.
if I evoke a function, then that function has to have IR.
Yeah, the function itself has the IR that says I plus plus less than length
Oh,
40,000.
okay. So my thought here of why that would be its own opcode is that I could potentially add like an aliasing annotation that says, okay, if you are if you are an initializer count, you like all loads and stores to this address can only be aliased by other like array init element instructions. So therefore LLVM could say, okay, there's two
Yeah.
pointers that are being loaded and stored from different locations. It doesn't know if they alias,
I
but
would
one of them is in the category of
I
this is
would I would claim he ought to be able to sort that one out, or certainly Java will sort it out. So I suspect LLVM will sort it out.
it'll do it in the case like if I have if everything's inlined, yes, it would find it out usually by itself. The problem is like, oh, there's a foreign function and I don't know what it does. If you put the
Uh,
aliasing instructions in there, like you can tell LLVM basically that some call is not going to write to some set of pointers or something like that.
like I'm envisioning.
Or like if you get returned a pointer from a function call that's foreign and LLVM doesn't inline it, you can say, okay, this pointer call, like if I load an address from that, that can never be something that came from a store to the address that came from the initializer because they have a different aliasing group. So
I'm imagining an implementation of array init that has these kind of things, plus a construct and a destruct. And I would claim that in Java, here's some code. And I claim in Java, Java would say, "Oh, you're the X field of the array init base. You only alias with other X fields of other array init objects of which there are none floating about, so you don't alias." I don't understand why.
yeah, maybe, but it's basically like type-based aliasing, but I can
Yeah.
say it's like instruction type-based aliasing. Like if I use this instruction, the pointers can only alias with things that are modified by the same instruction, so that could introduce a potential like load store
Well,
elision
all
where
right.
it's like, okay,
I'm back around to I think you're making trouble for yourself. Do the easy, obvious thing, whatever that happens to be, and worry about performance of things like whether or not this aliases later, because you can clearly tell LLVM, don't alias this field. I know there's annotations you come through. This guy is
well,
purely
also
never aliases. Fine.
also like implementing try catch is a lot of is more work than just this implicitly does the
Yeah. I mean,
unwind.
I cheated here all the way, and that I didn't. I had this the dot 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 in the constructor here has to say for x equals 0x less than max x plus plus destruct if fail.
Yeah.
Now jump to the destruct call, blah blah blah. There's a bunch of code in there.
I would argue that adding the constructor a destructor to the array initializer is a little bit more work. Also because like let's say that you successfully create the object, right?
I, I'm not actually right. I'm not expecting you to make it this way. I'm trying to get the semantics out. Like if I were to do this, I guess I have done this. I kept those as separate. I didn't make a struct array net. I just kept the fields x, max, and base as locally available variables.
So
And
if I like unwind it, right?
yeah,
I could, or like let's say I successfully construct and I call array init complete, right? And then I
yeah,
can say, oh, array init complete. Therefore, I've actually just removed the destructor of the array initializer from the unwind table at that point, basically saying, oh, you don't even need to look at this because like
right.
if you left it in the unwind table, it would enter the destructor and be like, okay, count remaining equals,
You okay? So that's a separate
whatever.
one in how tables are built for C or C++ or whatever, because Java certainly doesn't have any of that kind of issue. There is no consult the table in that way.
Yeah. So I'm thinking of like the current unwind table necessarily of like what are my stack values, and then like if I ret from the function,
Well,
I've
and
just like
don't optimize your unwind yet. That assumes you have to have super fast unwinds, like saying get your performance correct, then worry about the
well,
performance of
well,
your
I'm not even
construction.
talking about exception unwinding. I'm just talking about like normal return unwinding. Because like let's say I return from the function, right? Just a normal return. If that array initializer like sticks around, then kind of what happens, number one is you can't really transfer ownership to the array because like the array initializer kind of takes ownership of the like partially constructed state. So the complete like transfers it back to the array. So now you always like once you transfer like the destructor ownership back to the original array, you're kind of saying like this is a fixed number of iterations to destroy instead of a variable runtime determined number of iterations to destroy.
And
So
like I
you have
said,
that.
I think you're making a problem for yourself that doesn't
Well,
work or doesn't isn't necessary. Sounds to me like you're
well, because
adding
like
well,
it,
but I don't
it
see it.
if I exit from the loop, um, like at and I keep that array initializer around, and that's what causes the unwinding of the or like the destruction of the array, then that array initializer still has that count variable that the compiler is going to then check.
These
Like
are all
maybe
like
it's
dead
smart
things.
enough.
I don't understand. The code is trivial, all inlines. It's completely dead from the compiler's point of view. He throws it all away. There's no issue after he gets done with the optimizer.
Maybe, maybe not. Like maybe the compiler's not smart enough to figure out, oh,
Oh,
once we've
no, no,
returned
no,
from
no.
this branch,
No, no,
that
no.
means the object's fully
You are
constructed, and this is always
surely failing to trust LLVM to do basic shit. I certainly C2 will do this one. X plus plus less than max. Oh, he knows X is equal to max when he's done with this loop.
Yeah, this is
Absolutely.
trivial. This is trivial.
Yeah.
It's eat it for
right.
breakfast, not a problem.
Right. The problem is when there's a like an intermediate function call that who knows what it's
Well,
doing in
that's what the
between
foo
the
struct is. The foo structure is your intermediate function call. What the hell does this guy do? It's a constructor of a foo
well,
struct. Well, it opens a
it's
file system. It's got millions of lines of crap in its
right.
local
That's
file.
actually not what I'm worried about. What I'm worried about is like you have your array init, right? And so you call the constructor of array init, and you finish your array is fully constructed.
Uh,
Now you call a foreign function. This is not inside array init. This is just inside the code that creates
right.
the
As
array,
soon as
right?
yes, has nothing to
And
do
that
with nothing.
and
It,
that foreign function takes an address of your array or something, and then it does who knows what, and then it returns a pointer.
yes, this has
How
nothing to
do
do with
you
the array init object, which is now
right?
done and dead and can
Oh
be
well,
thrown away.
that's what the array init complete is for. It gets rid of the array init.
Um, yeah, like I said, I think you have making
So
yourself
so
trouble.
the complete the reason why the complete exists is that it says okay, the array is finished being constructed now, therefore I don't need the array initializer anymore.
Yeah, okay. Like I said, you're still making yourself trouble here. I wouldn't make an array init object that I didn't have to remove. But if I were to make an array init object, it would be obviously from trivial escape analysis that it is dead as soon as the array is done, and then that would be removed. And that would happen in my
Well, but
sure,
it's like a
correct?
runtime. It's like a runtime thing. So like if I go down a branch,
It's not a runtime
um,
thing. Nothing to do with
What do you
nothing.
mean? So like if I have my array init object, right? And the
I'm claiming you
counter,
shouldn't have one at all, but if you were, it would still be a pile of bits somewhere. And if I'm going to throw out, like, who cares? There's a pile of bits somewhere on an exception throw. There's a pile of bits somewhere. Okay, now I'm throwing out a foo struct. I go back to the array init object. I'm unwinding his destructor, and then I undo the destructor for array init, which is empty and does nothing, and I'm out. What's the issue here?
so one, I want to be able to pass ownership back to the array. So like I can't have the array init call the destructor and the array
Okay, so
itself call
ownership is a different
destructor.
thing. And that's one of the reasons I wouldn't have an array init here, because you're claiming I have to deal with ownership on it, and I would say no. So don't bother with an array init object. I'm trying to get the
Well,
semantics, and
how
you're
how
like,
do you
hey, the X will alias. I said, no, it won't alias. So here, put this together and make the X available for the construct and the destruct, but don't make the object struct array init. Hand inline the array init at each point because it's a small amount of code, and you're just going to have a IR spit out the build it loop and the destruct it loop.
Yeah, that's like it says array init new creates the initializer, checks if there are things that are left to initialize, and then it calls array init element, which like gets a pointer ish, well, a slot to the element, and then you invoke on that slot, and that constructs the
Yeah,
element.
oh, yeah. This code is what, except I wouldn't say array remaining. I would say, if x plus plus less than max, branch
Well,
around, don't.
that's the you get is there anything left, and then you branch on it. That's what I mean,
Yeah, I claim you can inline this opcode, and it's just as much opcode to inline it to be
so
x plus
like
plus less than
so
max.
make the array init remaining a branching instruction instead of a
No, makes array init remaining a plus plus and return a bool, which you're going to branch on. Except I wouldn't even do that. I would inline just the fucking plus plus as a thing and put a comp,
But I
standard
can't
comp.
because if I get so if I'm trying to take the element, right? So I'm getting the element. I can't plus plus it at that point because I haven't constructed the element yet. I've
No,
just got a reference to it. It's not alive. So I can't if I
what are you
plus
talking
plus
about?
already.
What are you talking about? As soon as you said array init new, you have some field slot, which I'm going to call x, and percent x equals 0. I have a field slot here. So I don't make all
Yeah,
my field slots up front like what you're trying to do. I make them, this is just a node in the graph. This is literally a constant node.
like
No slot things.
array init
Fine.
new is like taking a pointer to the array and then it's like a pointer of how many elements it's already constructed. Like those are like it's a struct that's like, okay, here's a pointer to the array, here's a pointer to how many, or here's a count of how many I've created, right? Well, that's the branch instruction down there.
I'm just doing a however you do plus plus here, and you loop through with compare your
That's
handing.
what array init element kind of does. But the
Right.
thing is that array init element, the reason it doesn't like instantly increment is because once I've gotten the element and put it into a
Oh,
slot, that object
fine.
is not alive at that point, right? Like I've just put
Right.
the element into a
So I'll
slot,
put
and
the
then I
put
have
the
to call
increment
the
afterwards. Fine. I don't care.
okay. So you could do that, but then
I don't know what your syntax
am
is,
I
but you're
incrementing?
storing array of percent percent x comma whatever your invoke was, your foo object you just invoked. And then when you fail, that is, you hit the unwind table on the invoke here. I guess the invoke still happens, and I'll make my store comment it out so it's separate. If you fail here, oops, random exception because the constructor blew an exception. Then when you jump to the unwind table, says jump to this place in the code, he picks up percent x there and has the unwind loop. That's what I'm thinking in this kind of an IR. And this is kind of what C2 actually does. The unwind table is
Mm.
no more than a jump. You're either leaving the block, leaving the whole function, or you just got a different jump. So X and X block here says, okay, and then what have you for loops here?
Mm, I mean,
Or whatever, jump below, jump less than equal. I don't care. followed by unwind.
So you're saying add an instruction instead of init element, like as soon as the slot is constructed, instead of implicitly advancing it, I just have a separate instruction that's like array init advance.
I'm saying as opposed to adding more, oops, wow, what'd you do here, dude? Go away. As opposed, I still can't hit Shift K. Wow, why can I not hit Shift K? Um, I'm saying instead of having these custom array init opcodes, they're replacing sort of very trivial opcodes. So just put the trivial opcodes in. Put a slot in for the how far. Put the compare, the branch you already have. You're going to call the invoke constructor. You're going to store the value, and you're going to increment and go again. The optimizer will totally clean that up and do the right thing. If you take the unwind table, you go to the exception block where you still pick up the same %x and you start counting it down, destructing as you go. This is sort of trivial IR. You've given the explicit semantics for an array init element and array init remaining because they're really obvious what they're doing. So why have a custom opcode for things you can do with bare opcodes? It's just a thing that you're going to have to inline later to the bare opcodes, and then it'll optimize it. Yeah.
Um,
I mean, this is my suggestion. I think we've beaten this dead horse many hours. It's time to be done.
yeah, I don't see like this is like creating a block for exceptions, which is exactly what I'm trying to avoid doing, is to have a separate
Well, you have
blocks
to
in
have
the
the
IR
code
for exception.
somewhere. So
It's
for
implicit.
C2, this is usually a deopt, which it's no more than a block of recovery of state in registers and whatever, and then a jump into the VM, which does the slow thing at runtime. That's your exception unwind thing. He doesn't actually does the trip count for the unwind loop typically. I
Right.
can
Well,
with this code. I don't normally.
the goal, of course, being that the unwind is implicit in the state of the slots. So
For
if
me,
I
the goal, the unwind is implicit because this program address if this function is not inline, then there is a stack frame, and the
I
address we return for the constructor call points to this piece in the code, and I have a table lookup that says, "Oh, that's my unwind table. Go to here and do the cleanup."
I would have to add like a try instruction in the middle there. So that's why I didn't do that. Because like
Well,
sometimes those functions don't even like maybe it can't throw an exception. So
that's
why is there a
fine.
try block?
Right. So I don't put a try in because I know implicitly every call can throw an exception. So I don't need to have a special try. If you're a function call, the body of the function, which I don't see in front of me, can throw. Period. End of statement. Okay.
But how do we get to the exception block?
The table internally, when I generate this block of code, internally I'll say at the address of the return of the constructor, there is a hash table mapping the PC of the return to where you're going to go, the PC
Like
of the target.
that's
Literally
that
the
is
runtime.
that like those blocks are the IR though. Like there's not a second set of blocks besides these. Like there's no additional
Yes.
table besides these instructions. So that has to be in a like
There's
block
an
three.
unwind table. There is an unwind table for C2, yes. And the unwind table does effectively a long jump. If you're coming back from the return of this constructor, you're going to long jump to here with an exception. You're going to long jump to here instead.
Okay.
It's not
Yeah,
really
I
a long
mean,
jump. It's a direct
yeah.
within function jump.
I don't see how I could apply that to this IR because like if the exceptions are implicit, like the
So
unwind is implicit.
so in the land of porting to LLVM, you have to teach LLVM when I unwind from here, what do I do? For
Yes,
me, I'm jumping over to here and say go here, and I don't know if LLVM has what's his unwind capabilities are. Go run
mine.
the code.
Okay, mine is like okay. I know how many slots are alive when I have an exception, so I can say at every point which slots have a live object in them or a
Yeah,
partial object, and then I can
yeah.
say, okay, I'm gonna generate
That's
a
C2 is
unwinder.
C2 is doing exactly the same thing in that sense. That
Right, but
whatever is alive at the time of this that has to be dealt with in the exception, whatever however you have to deal, he knows it, and he just writes the code here that says do the thing. In this case, it's a partial, whatever the partial array
yeah,
is.
So
but
the
other things happen.
the unwinding gets generated when we convert from this IR to the LLVM. This IR doesn't keep track because like it's implicit. Like you say, oh, if I'm unwinding, I have to
All right.
destroy
Yeah. All right.
the things on the slot
Yeah,
stack,
yeah, yeah.
basically.
We're I think we're at a point where we agree to disagree. I just exposed it and I walked away from it, and it worked out well for me. You want to not expose it, so you need to have a thing which is exposed, which represents the partial array, which is your array init remaining. Some piece of this says this is the partial array, and then you'll explode that out at some translation step later. And I think your approach will work. It's not the one I would take, but that doesn't mean it's a bad one. Do what you're gonna do. Okay. I think we're running out of time, and we, like I said, we beat this dead horse a whole lot. How to handle exceptions and how to handle constructor of arrays with non-trivial bodies, where you want to destruct virtual array or contents of partial arrays and stuff. All right, anyone else want to add anything? Because I'm headed for calling it here.
Probably a thing to do next week, not now, but one of the things people talk about with exceptions versus if statements is the efficiency of the call and wanting things to not have instructions or jumps where they're very rarely needed.
Yeah.
And to what extent you can do that entirely automatically by just noticing that the counter is super lopsided
Yes, that's a
and
performance.
say,
Yeah.
I don't even want an if statement here. I just want to like dereference invalid memory if
Yeah.
this doesn't work and then unwind it.
Yeah, C2 definitely does that for the memory case. I have a null check. I believe it to be rare in one way or another, and I'll do that. And you can have user written null checks, same as the safety checks that get built into the bytecodes. He just asks the frequency question, and then he pushes the test onto a bad, a faulting load op, a faulting
Are
op.
there other places where you expect something to be so rare that you
You have
actually
to have
want the
a faulty,
CPU to do some kind of CPU interrupt thing rather than
right?
having the jump that the
No,
branch
well,
predictor predicts correctly?
not really, because I can't be guaranteed it will fail. Like, suppose I know that array index out of bounds is rare here, and I want to take the exception, and you do in fact go off the end of the array. Do I get a guaranteed exception fail? Only if the array is at the edge of the TLB map memory, right? Only a map memory edge. So he doesn't do that one. I do cases where I think that you're going to fail. I'm sorry, the other way around. I think you're not going to fail, so I'm going to pre-do a lot of work. And that's just loop invariant code motion, right? I have
And you
loop
just at the
body.
end check it and throw it out.
I'm sorry.
Because I was thinking things like, I'm writing to a file. What are the chances that the person has yanked the USB drive out and the whole file system is just gone?
Right. Well, it would be I'm making a foreign function call to the OS, and it's going to
Like,
give
I
me an
don't
error
really
code.
want an if saying, did the OS come back happy each time? Or maybe I do.
No, on IO you do. The IO is so slow compared to the CPU. You just check IO every time. That's not a problem. No, it would be something like I have a 4 byte no byte reversal code. It's going to take 4 bytes and reverse them, except that he's in the middle of some big array where he's doing partial byte reversal. And is he going to run off the end of during the partial byte reversal? Well, I'll arrange my range checks for the 4 byte reversals to pre-fail ahead by looking, do I have at least 4 elements left? And if I do, then I don't have to have any range checks for element by element when I grab the four and reverse them. And if I don't, then I'll go to the slow code, which does it exactly as your Java bytecodes one
You're
at a
perfectly
time.
happy to
Fails.
read into the register past the end of the array as long as you catch it before you
Yeah,
move on.
yeah, that happens too. That's as long as right, especially if I'm doing sim deops, where I'm going to run around and I know due to alignment I can read fat, but I don't need all the elements that I just read. So I'll yeah. You're
And those just
asking,
seem
are
like
there
things
other
that are
places where
essentially never going to fail because, they only happen once at the end of the array of a billion things.
Yeah, and I'll know due to alignment that they won't fall off the edge of a TLB a boundary, so I won't get a TLB exception. I just have loaded some extra bits.
So there are times when you don't want to turn everything into an if, that the hardware is helpful.
Well, that's what I'm saying. I don't really do the end of the universe ones. I do null pointers for a hardware fail.
Yeah. Okay. That was a shorter answer than I expected. Thank you.
Yeah. Yeah, I'm thinking what other things I do that would turn into a hardware fail. I don't, as far as I know, it's just the null pointer check.
Yeah,
All
there's
right.
nothing like an x86 assert at this moment. Go look in the interrupt table if it fails.
Right.
I guess math is a little bit like that because there's questions of whether you checked the overflow bits.
I think Azul had they had a compute memory address and check for overflow. It was a shift scale add and go to the base of the memory and load the word that would be the array length and compare it against your index that you're shift scaling adding and throw. And if it didn't throw, then you got the complete offset pieces. Um, I think we were looking at it or we did it. And of course, if I've range checked eliminated a loop, none of that happened. But if you have a lot of junk, short, tiny loops floating around, you have to range check and do, and range check and do, and range check and do. You had a
The
shorter
ARM
opcode. I
chips
think
have
Intel has
anything
like
in
the
hardware to
bound
do something
instructions.
like set this register that tells you where to jump to in the event that one of your math ops overflows?
Um, I don't think Azul had overflow math. The
I think
normal
some
like
chips
Sun
will let
had
you set a specific register that's like, here's the address to jump to on math being sad.
no on known throwing instructions, which Azul did not have for overflow math. So the range check, bounds check, null pointer, this, that, a bunch of things. You jumped to a fixed known address in user memory. It was
Okay.
just this instruction jumps to this address. And as part of the VM state, you shove down there a jump to where you're going to handle the code. You
And it was just
put a handler
whatever
there.
function needed to set that address was responsible for setting it.
Yeah, somebody at the start of the VM came up and said, at address 100 hex, it's the range check blew
Does
out.
something prevent threads from racing on setting those?
Well, no user mode Java thread could set that. That was the VM's beginning.
I see.
Which one are we talking? Yeah, there was no user mode deal at the Java level, deal with an exception and jump to an address that was fixed of any kind. No. At Java level, you wrote try finally or try catch, and at the bytecode level, you had a pile of bytecodes with a catch table.
There was someone I was talking to who I used divide by zero as an example of a thing that never happens. And he was like, oh, it happens. You don't
Yeah,
really need to treat divide by zero as a super, super rare event because it's not as rare as you think it is in
Java
production
demands that you
packages.
handle the exception throw, and so typically you get an if check because you can't prove it. You typically get an
Yeah.
if check known to be super low frequency, but you actually get an if check in the code. So like in the land of x86, I think most CPUs or many at least do this now, where you predict branches as forwards branches as not taken, backwards branches predicted taken, forward predicted not taken. And if you predict correctly, you don't pollute the branch target buffer. You don't pollute the branch prediction tables. And you have a million such branches because you're doing safety checks everywhere. As long as you predict correctly, it doesn't blow out your branch table, which means that your branch table can actually handle the branches that you can't predict well on. So everywhere where you know what the frequency is, you arrange the branch to go the way it'll predict correctly, like your divide by zero knows to not jump. So the fail case is put forward, which means you do block layout, you just lay out the fail case ahead of you. Then it doesn't cost you any in your branch target buffer. He predicts correctly. And then on an x86, that's certainly like one clock cycle, half a clock cycle at best.
That
So
was
just
the
say,
first example that anyone ever introduced me to Godbolt on.
hmm,
Was this optimization where you force it to go through the loop and be a very predictable if going the wrong way. And
yes.
you get this sort of funny dance of a non-conditional jump to a conditional jump so that the jump's going to be going the right direction.
Yeah. I mean, I did a lot of that
Potato.
stuff way back in the day. That was you laid your blocks out. So you branched forward to the fail, and you did a short branch forward to the fail, which meant that interleaved with the normal regular code, there was little tiny snippets of this is the fail that's forward, so it predicts correctly, but I don't want to handle the fail right here, so I'm going to jump again, but I don't care if I'm slow on the second jump. So, yeah,
Yeah, so there's some funny jump patterns that you look at and you're like, why are you doing that? And it's like, oh, you're doing that so the branch predictor won't pollute its state.
won't pollute its table. Yeah, and now you can have a million billion predicted branches, and they're all a clock, half a clock, and you still have a branch predictor for all the ones you can't get right. Yep. All
Yeah.
right. There was an interesting purview of a different way to think about array initialization, Ryan. I think the primary cause of confusion for me was not getting your undesire to expose now, but to do something based on lifetime of things, and that's where your funny opcodes came from, so that when you had to do the unwind, it could do it on lifetime of objects you had lying around. And I would just approach that problem a different way.
Clearly, the answer is to give up on malloc and just allocate all memory at compile time.
There you go.
Just put everything in globals for the whole program.
Yep. I think NASA has a rule about that when doing like Martian rovers and shit.
Yes, the only place I've ever seen that is inside a radar system. That
Okay, yeah, yep.
literally every variable for every function. There was no heap, there was no stack. The
Wow.
compiler decided where to put everything all the time.
Well, there's certain simplicity there. Yeah, yeah. Okay, I guess I've seen that in 60s Landsat satellite data on the processing on an ancient
For all I
TI-82
know, this code was
technology.
written in the 60s.
I'm sorry?
I said, for all I know, this radar code was written in the 60s.
Yeah, it could have been.
I don't know malloc, but no stack. That's
Yeah.
interesting.
You still can get function calls. You just can't be recursive. A calls B, and when A calls B, it was the jump and link
Yeah.
register instruction. It was
The
IBM's jump and
functions were
links.
laid out with all of their local variables and return values
Yeah,
at the head of the function.
yeah. And then the jump and link said, I put the link value in a register, and the guy I called stores it in a place on his fixed memory space, no stack, on a fixed place,
Yeah.
and he jumped back to it.
This code base was just flat out recursion's illegal. Don't.
Recursion is just illegal. But if you're writing a radar system, you probably don't want recursion. Now
You
you don't need a
probably have to
stack.
put you probably have to put the return address somewhere, right?
No, he puts
Because
it in
The
his,
return register.
yeah,
okay,
right.
return register.
The,
Yeah.
the, the jump and link puts return in a register. The guy who got called, if he wants to call somebody else, there's no recursion, but he's A calls B calls C calls D. Then B takes his return register and throws it onto his private local stack variable, not stack,
Yeah,
private local variables, no stack.
yeah,
And then
yeah.
he goes on the next one.
Interesting.
Yeah.
I mean, don't get me wrong, the stack was a good invention.
But if you're looking for deterministic everything and you don't have recursion, you don't have stack depth issues. It's
They
makes it
wanted
not
very predictable timing. I
very
think
predictable.
is their
Yes. Okay.
justification for.
Fun stuff next week. Bye bye.
Yeah.